Welcome to Tectonic Nights channel. Here's day 8 of solving easy LeetCode problems in Python. Today's problem is given an array nums sorted in non-decreasing order. The task is to return the maximum of count of positive integers and count of negative integers in the array. Let's start with the brute force approach. We start by initializing two variables to 0. These will keep track of the count of negative and positive integers in the given array. We iterate through each element of the nums array, checking whether it's positive or negative, and increment the corresponding count. Finally, we return larger of these two counts. Time complexity here is O of n as we process all the elements in the given array. Let's try to optimize the time complexity from O of n to O of log n by using a binary search approach. Let's walk through the logic behind finding the count of negative and positive numbers in an array. The idea is to first identify the position of first occurrence of 0. If there are no zeros in the array, we find the first occurrence of a positive number. Now let's dive into the binary search algorithm. The idea is to repeatedly divide the array in half and check the middle element. If the value at mid is 0, we return that position. If the value at mid is less than 0, we know we need to move towards right side, so we shift the left pointer to mid plus 1. If the value at mid is greater than 0, we need to move towards left side, so we shift the right pointer to mid minus 1. Here in the first iteration, mid is at index 3. We return the mid value, which is also the first occurrence. But what happens if we modify the array? Replacing the element at index 2 with 0. In this case, we might spot a 0 at index 3 during the first iteration. However, this is not the first occurrence. So to ensure we find the first occurrence of 0, we need to tweak this binary search algorithm. When mid equals 0, instead of returning mid, we update the right pointer to mid minus 1 and continue the search to the left side of the array to ensure we find the first 0. In the first iteration, we update the right pointer because the value at mid is 0. In the next step, mid is minus 2, which is less than 0, so we shift the left pointer. Now both left and right pointers are pointing to the same element, which is minus 1. Since it's less than 0, we move the left pointer. At this point, the left pointer becomes greater than the right pointer, so we exit the loop. The left pointer's position is now the first occurrence of 0. Next, let's test if the same algorithm works for finding the first occurrence of 1. In the first iteration, mid is less than 1, so we update the left pointer. In the next step, mid is equal to 1, so we move the right pointer. After that, mid becomes 0, which is less than 1, so we shift the left pointer again. Now the left pointer is greater than the right pointer, so we exit the loop. The left pointer's position is the first occurrence of 1. Finally, let's see how the algorithm behaves when the target is 1, but the array does not contain any 1s. In the first iteration, mid is 0, which is less than 1, so we shift the left pointer to mid plus 1. In the second step, mid is 2, which is greater than 1, so we shift the right pointer to mid minus 1. Now mid is 0 again, which is less than 1, so we update the left pointer. Since the left pointer is now greater than the right pointer, we exit the loop. At this point, the left pointer points to the first occurrence of a positive number that's greater than 1. Now we can use this algorithm to find the first occurrence of 0, which will tell us the total number of negative integers in the array. For example, in this case, the first occurrence of 0 is at index 3, meaning there are 3 negative integers in the array, from index 0 to index 2. Next, we find the first occurrence of 1. This gives us the index of the first positive number in the array. In this case, the first occurrence of 1 is at index 5, which is the starting index of positive numbers. To count the number of positive integers, we subtract the index of the first positive number from the array length. This will give us the count of positive numbers. Now let's dive into the coding section. We start by initializing two pointers, left to 0 and right to length of nums array minus 1. Next, we define a binary search function that takes a target as a parameter. Within the function, we iterate using loop that continues as long as left is less than or equal to right. In each iteration, we calculate the mid index. If the value at mid is less than the target, we move the left pointer to mid plus 1. Otherwise, we move the right pointer to mid minus 1. To count the negative numbers in the array, we call this binary search function with a target value of 0. To count the positive numbers, we call the binary search function again with a target value of 1. This result is subtracted from the total array length to get the number of positive numbers. Finally, we return the maximum of the counts for negative and positive numbers. Thanks for watching. If you enjoyed this video, give it a thumbs up and subscribe for more content. Stay tuned for more videos in this series. Let me know your thoughts in the comments below. See you next time.